Hello and welcome. I am Dr. Gerlina Fernandez, Associate Professor, Department of Mathematics and Statistics, the Bhopal School of Social Sciences. Dear listeners, in the previous module, we have discussed about the definition of linear differential equation, the standard form of linear differential equation, steps used to solve linear differential equation. So, in this module, we are going to practice some numerical questions related to linear differential equations. But before moving on, let us recall the steps that are used to solve linear differential equation. So, let us begin. So, as you know, linear differential equations are of two forms. The standard linear differential equation in y is dy by dx plus py is equals to q, and the other form is dx upon dy plus p dash x is equal to q dash. So, we have two forms of linear differential equation, one is in terms of y and the other one is in x. So, this is in y and the other one is in x. So, we have to find the solution, that is the steps to solve linear differential equation in y and in x. So, the step number 1 is you have to write the given differential equation in its standard form. So, this is the standard form in y and that is the standard form in x. So, this is step number 1. Now, in step number 2, we have to write the value of p and q. So, p in this particular equation, p is the coefficient of y and q is the RHS of the given differential equation. Similarly, in this form of linear differential equation, p dash, we have to write the value of p dash. So, p dash will be the coefficient of x and q dash will be the right hand side of the given differential equation. So, first step is to write the given differential in its standard form. That means one more thing you will have to keep in mind, that the coefficient of dy by dx should be 1 in both the cases. Next, step number 3, after writing the value of p and q, then we find the integrating factor which is given by E integral p dx in case of dy by dx plus py is equal to q, and in case of linear differential equation in x, the integrating factor is given by the formula E integral p dash dy. So, here the dependent variable is y and the independent variable is x. So, here we integrate the value of p in terms of x, and there in the second form the independent variable is in terms of y. So, we integrate p dash with respect to y. So, this is the third step. Now, in the fourth step, step number 4, we write the general solution of linear differential equation. So, solution of linear differential equation is given by the formula y into integrating factor is equal to q into integrating factor dx plus c. So, here we have y into integrating factor is equal to integration of q into integrating factor dx plus c. So, this is the solution, the formula for solution of differential equation of the form dy by dx plus py is equal to q. Now, talking about the solution of this form of differential equation. So, solution of linear differential equation in x is given by the formula x into integrating factor is equal to integration of q into integrating factor dy plus c. Here you will have to keep in mind that the dependent variable in this differential equation is y and the independent variable in the equation is x. Whereas, if we talk about the second form, here the dependent variable is x and the independent variable is y. So, accordingly we will write the formula for the solution of the differential equation in y and the differential equation in x. So, here y is the dependent variable, there x was the dependent variable, and we integrate the function with respect to the independent variable. So, in this case the independent variable was x and here the independent variable is y. So, this is the working rule for solving linear differential equation in form of y and in form of x. Now, the usage of these steps can be more clearly understood through the following examples. So, let us begin. So, the first question is you have to solve x dy by dx minus 2y is equal to x square. So, before solving this question, let us understand what do we mean by equation. differential equation and linear differential equation. So first is an equation. So equation is a mathematical expression which consists of variables, constants, operators along with the sign of equality. So that mathematical expression is called as an equation. Now what do we mean by differential equation? So an equation which consists of dependent variables along with its derivatives, those equations are called as differential equation. Next is linear differential equation. So we can write an example of differential equation, that is dy by dx plus 6y is equal to 0. So this is an example of a differential equation wherein we have dependent variable. The dependent variable is y. The independent variable is x. So in this particular equation, we have dependent variable along with its derivative. So this equation is called as a differential equation. Now next is a linear differential equation. Linear differential equation. So if the power of y and its derivatives, if the power of y, that is the dependent variable, and its derivatives, if they are in degree 1, then we say that this differential equation is called as a linear differential equation. So if the dependent variable y and its derivatives that are appearing in the equation, they all are of order, or they all are of degree 1, then that differential equation is called as linear differential equation. So this example is of linear differential equation because here the dependent variable y and its derivatives are of degree 1. So this is an example of linear differential equation. So we are solving linear differential equation with the help of the methods that we have discussed earlier. So first step is to write the given differential equation. So given differential equation is x dy by dx minus 2y is equal to x square. Now you will have to compare this equation with the standard differential equation in y, that is dy by dx plus py is equal to q. You have to compare the given equation with the standard equation. So first thing is that the coefficient of dy by dx should be 1. So here you can see that the coefficient of dy by dx is not 1. So what we will do? We will divide the whole equation by x on both sides. So next step is we will divide the above equation by x on both sides, so that we can convert it into a standard form of linear differential equation. So this will become dy by dx, x we are dividing it by x, so minus 2y by x is equal to x square by x. So we have divided the equation with x. Next step, we will cancel it out and the equation will be dy by dx minus 2y by x is equal to x. So this is equation number 1. Now you can compare it with the standard form. Here the coefficient of dy by dx is 1. We have the value of p as well as the value of q. So here p is what? P in this standard form is the coefficient of y. So here the coefficient of y is, you will have to take the constant along with its sign. So here the value of p is the coefficient of y, that is minus 2 by x, and q is the right hand side of the given differential equation, that is x. So this is step number 2, wherein we have to write the value of p and q. Next step is we will find the integrating factor. So it is given by the formula if is equal to e integral p dx. Substitute the value of p and integrate it. So here the value of p is minus 2 by x dx. We can take minus 2 out of this integration, and as we all know that integration of 1 upon x dx is log x. So we will substitute the value. So if is equal to, here the value of 1 upon x dx is log x, so we will put it here. So if is e raised to the power minus 2 log x. Next, here we can use the property of log. So the property of log is n log m is equal to log m raised to the power n. So the coefficient of this log comes in the power of m. So if is equal to e raised to the power log x raised to the power minus 2. So, the coefficient of log x was minus 2 and it now becomes e raised to the power log x raised to the power minus 2. Now, again we have a property of log that you have already studied, that e raised to the power log x is x itself. So, in the similar manner, here the value of if will be if is equal to x raised to the power minus 2 or 1 upon x square. Now, this is the value of if from step number 3. Now, moving to the step number 4, you will have to write the formula of general solution for the linear differential equation. So, therefore, the solution of equation number 1 is given by the formula y into integrating factor. Here the dependent variable was y. So, y into integrating factor is equal to integration of q into integrating factor dx plus c. Here c is the constant of integration. So, substitute the value of integrating factor, that is y, into 1 upon x square is equal to q is x into integrating factor, that is 1 upon x square dx plus c. So, here you can see that we can cancel x from the numerator and denominator. So, we will have y by x square is equal to integration of 1 upon x dx. So, integration of 1 upon x is log x. So, y upon x square is equal to log x plus constant of integration c. Next step, we have to find the value of y. So, we can shift this x square to the right hand side, multiply it with the terms that are in the right hand side. So, here we will get y is equal to x square log x plus c x square. So, this is the value of the given differential equation, y is equal to x square into log x plus c x square. So, the next question is, you have to solve 1 plus x square dy by dx plus 2xy minus 4x square is equal to 0. So, this is our given linear differential equation. First, we will write the given differential equation. Then we will compare it with the standard form. So, the standard form is, since here the dependent variable is y, so this differential equation will be dy by dx plus py equal to q. So, this is the standard form of linear differential equation in y. So, first you have to compare it, that means the coefficient of dy by dx here should be 1, and here you can see that the coefficient of dy by dx is 1 plus x square. So, what we will do, we will divide the whole equation by 1 plus x square on both sides. So, that will become 1 plus x square, we will divide with each and every term of the equation. So, plus 2xy 1 plus x square minus 4x square, which we can write it as, since we have to convert it into a standard linear differential equation. So, here you can see that we have a q. So, next step what we can do, we can shift this 4x square to the right hand side and then we will divide it by 1 plus x square. So, here we will cancel out the terms 1 plus x square, and finally we will have dy by dx plus 2x upon 1 plus x square multiplied by y is equal to 4x square divided by 1 plus x square. So, this is the standard form of linear differential equation. So, step number 1 is completed. Now, step number 2 is that you have to find the value, write the value of p and q. So, here the coefficient of y will be 2x, coefficient of y you have to compare it with this form. So, the coefficient of y will be p and the right hand side of the differential equation will be q. So, this is the value of p and that is q. So, write the value of p over here, we will get 2x upon 1 plus x square, and the value of q is 4x square divided by 1 plus x square. Step number 3 is to write the formula of integrating factor. So, here if is equal to e integral p dx, substitute the value of p, that is 2x upon 1 plus x square dx. Now, here you can use the method of substitution, or you have a formula for integration, that is integration of 2x, or you can write integration of f dash x upon f of x dx is equal to log f of x. This is one formula that you have studied in class 12th. So, integration of f dash x, that is the derivative of f of x, divided by f of x dx is equal to log f of x. So, here you can see that in the denominator we are having 1 plus x square, and the derivative of 1 plus x square is 2x. So, we can use this formula. So, we will have e log of f of x. What is f of x over here? Here f of x is 1 plus x square and f dash x is 2x. So, you can compare it with the standard formula. This one is the standard formula. Integration of f dash x by f of x dx is log f of x. So, here f of x is 1 plus x square and f dash x is 2x. So, we can write e raised to the power log f of x is 1 plus x square. Now, again we have the property of log. The property of log is e raised to the power log x is x itself. So, we will use this property and get the value as 1 plus x square. So, this is the value of the integrating factor. We complete with the step number 3. Now, step number 4 is you have to write the formula for general solution for the linear differential equation. So, therefore, the solution of equation number 1 is y into integrating factor is equal to integral of q into integrating factor dx plus c. Substitute the value of integrating factor, that is 1 plus x square is equal to the value of q was how much? The value of q was 4x square divided by 1 plus x square. 4x square divided by 1 plus x square multiplied by integrating factor. So, integrating factor is 1 plus x square again dx plus c. So, here you can see that we have like terms, so we can cancel it out. So, 1 plus x square will get cancelled and we have 1 y into 1 plus x square is equal to 4 times of integral x square dx plus c. So, here we have a formula for integration. We have to integrate this part. So, we have a formula for this. Integration x raised to the power n dx is equal to x raised to the power n plus 1 divided by n plus 1. So, here you can see that the value of n is how much? The value of n is 2. So, we will substitute the value and rest everything will remain the same. So, 4 multiplied by x raised to the power 2 plus 1 is 3 divided by 3 plus c. So, or we can rearrange it and write the value of y as this is 4 by 3 x cube divided by 1 plus x square plus c divided by 1 plus x square. So, this is the solution of the linear differential equation. With this we come to the end of this video. I hope this was a good learning experience for you all. In the next video we will be discussing about Bernoulli differential equation. Thank you.